So welcome. I'm Łukasz Górnicki. I'm at the moment one of the maintainers of AsyncAPI generator and AsyncAPI specification. And today I'm going to talk to you about basically AsyncAPI, how it can be used in production. Everything I do for AsyncAPI, it's purely for passion. So if you want to learn more about my open source passion, AsyncAPI passion, I have my brand called brainfart.dev, which is very encouraging to join. I have a lot of content there about open source, which might inspire you, so have a look later. Now, the most important, I think, at the beginning is to figure out actually how many people know AsyncAPI before I actually jump into how AsyncAPI is used in production. Can you raise your hand who's using AsyncAPI? Who knows anything about AsyncAPI? Okay. Who knows OpenAPI? Okay, awesome. So AsyncAPI, it's just like OpenAPI. So it's inspired basically basing on OpenAPI, but it's different because AsyncAPI is designed for event-driven architectures. So all the different protocols you use for asynchronous communication, like WebSocket, Kafka, MQTT, basically you name it. There's a huge zoo of different protocols. And OpenAPI is for HTTP, for RESTful communication. So that's the difference. But when you look at the structure of AsyncAPI documents, it's very much similar if it comes to complexity of the structure. AsyncAPI is actually more complex because it's not just HTTP. There's a lot of different protocols available. So it's basically, as you can see on the screen, that's actually a screenshot from our website. As you can see on the screen, on the left-hand side, you can see this example AsyncAPI document. So it's basically YAML or JSON. It's a structure, complex model that you can use to describe connectivity between your applications in event-driven setup. So you can describe producers, consumers, what schemas they use, what topics they publish to or consume from, all these details that later on help you to do a lot of cool stuff because, again, it's a machine-readable format. When I compare to OpenAPI, one thing is the benefit is that it's easy to understand, map mentally what you know about OpenAPI to AsyncAPI. The problem is that even we suffered from this mapping, and our website mainly promotes AsyncAPI as a tool to basically render documentation, which is not the best. You can really do much, much more. But that's gonna change soon. Thank you, Shreya. So we're gonna change it finally. But yeah, remember AsyncAPI and also OpenAPI or JSON schema. Whenever you have some spec, whenever you have some machine readable format where you can describe the connectivity, describe your architecture, please don't use it just for docs. Docs should be really side effect because even OpenAPI or AsyncAPI, it's a complex solution. You really have to put some effort into understanding to make sure that you describe everything well. So yes, at the end of the journey, docs should be just a side effect of much, much bigger investment. So everything you're gonna hear today during this presentation, really short presentation where I'm gonna have to skip a lot of slides. Everything was a part of research I started I think 2 years ago, basing on a really inspiring discussion with guys from Gartner, where they said we really have to show how AsyncAPI is used in production. So you can go to asyncapi.com/case studies later on, and you're gonna see that whatever I showed you, it's based on the research, on information about from different companies. We were inviting basically different speakers to different conferences that we organized, and we were basically listening how they use AsyncAPI already in production. The problem is that you're gonna have only 3 logos over there. So over 2 years, I'm not good. In 2 years, I just managed to collect 3 official case studies. Rest is just a list of videos, a list of articles, a list of different informations. But it's because Asynchronous communication is mainly used to solve internal challenges that you have in your companies. You're gonna use Kafka or Pulsar, but internally, nobody's gonna set to the outside world information about how they use Kafka, what topics they have. So companies automatically, they're not so open to basically share internals. Even if we convince them that they can really anonymize a lot, they're basically afraid. There's also a lot of politics. Everybody likes to use open source, but not everybody wants to admit that they use open source and put the logo of the company and put some details on the website. So I encourage you, if you're already using AsyncAPI or you're gonna start using AsyncAPI, then please come over, tell us how you use it, so we can also share it with others, because like you're gonna benefit from the learnings basically from others. It's not just for us, it's basically for you. So I skipped a lot of slides related to how what different industries use AsyncAPI, what different protocols I used. But basically the goal of these slides was to show you that basically there's no specific industry that only uses AsyncAPI. It's e-commerce, it's robotics, it's basically anything, finance, insurance, because in the end, AsyncAPI is not tied to a specific industry, it's tied to one specific problem where at some point of time, you don't want to do REST, you have to scale, you have to introduce event-driven architectures, and that's gonna happen in any industry at scale. If it comes to protocols, again, there's a zoo of protocols, which is in the end not bad. It's just because they solve different issues. If you do IoT, you're gonna do MQTT. If you're gonna do microservices, you're gonna look into Apache Pulsar or Apache Kafka. So it's completely fine that we have this zoo. There are actually companies like Lego that use multiple different solutions for event-driven architecture. They use SNS SQS from AWS. They also use Apache Pulsar. So don't think that you should just stick to one solution. First think about what problem you want to solve and then choose the right tools. So the breakdown, let me just quickly go through the breakdown to show you that at the moment there are 8 use cases we already noticed people do with AsyncAPI, and only one of them is used for documentation purposes. So you can already see, like, again, it's a machine readable format. So the sky is basically the limit if it comes to imagination, what you can do with it, what problems you can solve with it. And now I'm gonna just basically go through each of them and try in 10 minutes to give you a feeling like what people do with AsyncAPI. And let's start with my favorite, which will take most of the time. So like something that during the learning and my research, I found like really mind-blowing, because this particular use case is solving one of the biggest issues you have in API world, especially when you use specs. How many of you know about API drift? Do you know the concept of API drift? Okay. Do you, so folks that use OpenAPI, how many of you generate it just from the code? Okay. How many write it by hand? Okay. So there's this saying that once you create AsyncAPI or OpenAPI document, the moment you create it, it's already outdated. Because usually people do it as a side task, especially, I mean, developers, they prefer to code than write YAMLs, unless you're already working for years with Kubernetes, then you're getting used to it. But nobody really likes to do it. So the thing is that you're using OpenAPI, you generate it, you publish the docs, but then at some point of time, they're really drifting from the actual implementation. So that's the API drift. Like basically your docs don't really reflect the reality, even though you generate it from code. If you know, probably happened to you as well, that even if you generate it from code, you might forget sometimes to add some annotation in your code to generate something. That happens. And here the beauty is that AsyncAPI is treated as configuration file. So this is the slide from the presentation from Kuhn and Nagel, pretty cool guys that They're actually based in Portugal, but they're working. It's a German logistic company, huge logistic company that has a lot of challenges managing ports, of course. So they do it at scale with MQTT and Kafka, because usually when you have a lot of devices sending MQTT, then in the end, internally, you're gonna aggregate everything in Kafka. So they found a solution for the API drift, basically by using AsyncAPI as a configuration file or input for configuration files for the infrastructure. So basically if the team wants to have, for example, new topic in Kafka, it's not a Java issue that they have to create to the DevOps team or something similar. It's just that they have to upload their AsyncAPI document through CI/CD into the system, like make it discoverable. And then in their case, they use Argo because they're using Kubernetes, but you can do it any different ways. Lego does it basically basing on, they just have services that serve as a CI/CD. So basically, AsyncAPI, because it has information basically about all the schemas, about all the topics, so they extract this information and they generate Helm charts that contain definitions of custom resource definitions. So in Kubernetes, when you're doing Kafka on Kubernetes, you're most likely going to use a project called Streamzy, which is like an operator for Kafka. So what they do, they take AsyncAPI document and they generate Streamzy resources. So that later on are applied to the cluster. So team, basically, to get access to the infrastructure, any kind of infrastructure, dev or prod, they have to have an AsyncAPI document. And as you can imagine, they have to have a real AsyncAPI document with accurate information in it. Because if they will, for example, develop some new feature, but they will forget to put it in the AsyncAPI document, let's say they produce new events to new topic, maybe locally it's going to work, but the infrastructure will not be provisioned for them in the integration or production environments. So AsyncAPI is basically contract, a config that you have to rely on. And then you don't have to force teams. It's not that you don't force teams to use AsyncAPI. They just treat it as a part of the infra, as a part of the process that they just have to follow. And every company does it differently. So it really depends how you do it. Again, depends on your organization. Kune, as I said, does it on Kubernetes. Raiffeisen Bank also very similar. They do it with Apache Pulsar, but also exactly the same way in pure DevOps in the cloud. Postman, when I was still working at Postman, I remember how it looked like. I know it's changing a bit, but the goal was the same. So the Postman workspaces, it was basically all the teams, if they're building something for Postman workspaces, they had to basically request new queues through AsyncAPI documents to get access to SNS and SQS. But there are some changes in the architecture. But yeah, Schwarz Group, big German company behind Lidl and Kaufland shops, exactly the same reason. They just want to have AsyncAPI as a config. And now, for minutes, the rest. Self-service, very much related to config, because AsyncAPI can be, if it's treated as a config, like everybody can upload it somehow, somewhere. So again, it's not only about the topology of the brokers that you control. Like, for example, Bank of New Zealand, you can do much more. So you basically tell the team, you just maintain AsyncAPI document, we give everything to you. So for example, they have nice self-service way where a team gives you AsyncAPI document. They of course give you the access to the infrastructure, but they also take your AsyncAPI document and also automatically put it in the developer portal. They also do some magic to extract schemas from the AsyncAPI documents and publish them in the schema registries. So they're widely available in the organization. So again, AsyncAPI, machine readable format, that's what enables you to do in the organization at scale. Anybody using Kafka? So in Kafka, there's this really nice feature called dynamic topics, where you can like pretty quickly create topics. But there's also another thing, topics naming convention. like back in the times when we were arguing if we want to use comma or semicolon or whatever. In every organization, at some point of time, you're going to face this discussion like, how do we name topics? What information we should put in the topics? Now, once you solve it, the problem is how you make sure that everybody actually follow the same guideline. And that's what AsyncAPI, like just open API for REST. That's how AsyncAPI can be used. So every team, if they use AsyncAPI, they provide name of the topic in the AsyncAPI documents. You can have a lot of different linting governance tools plugged into the whole workflow. So you, for example, get quickly information that your topic is not really following the guideline. So it basically allows you to assure the consistency across the whole organization, which is if it's consistent, then its development cycles are quicker and nicer. QNS monitoring. I'm gonna have to skip this one, although I love the idea how they use AsyncAPI extensions. Cost reduction, very much related to config as code, but I'm explicitly mentioning it because it's really important. For example, what was the motivation for Lego? It was not much the API drift, it was the cost reduction. Because at the beginning, they had like full freedom for devs to create dynamically topics on the cluster. But with Kafka, it means like the more topics you have, the more clusters you have to have, the more costs you have to cover. So basically they wanted to block dynamic topics creation to reduce the costs. But of course they didn't want to slow down development. So they enabled this self-service by treating AsyncAPI as a config. So all the teams, they have to just go through their APIs to get access to the infrastructure, to get access to actually be able to publish to the topics. So it's connection of AsyncAPI as a config, self-service, but purely for cost production in the organization. Code generation, okay. Code generation, my favorite, because I'm the maintainer of AsyncAPI generator. Again, you can generate whatever you want. There are companies like Adobe. They just use AsyncAPI as a source for generating the data models, the classes. But I think you can actually do more. You can do client generation, SDK generation as well, like consumers, producers code. All of this you can generate. And again, like if you treat AsyncAPI as really a config, you can also generate YAML files. Just like the other guys I mentioned, they generate from AsyncAPI document Helm charts. So all of it is possible. These companies already do it. The Open University of Catalonia is doing it pretty nice. They have a lot of open source tools in the Eclipse environment. So yeah. Testing and mocking. At the moment we discovered 2 companies, and TransferGo is actually the latest case study. And they both here use a project from CNCF, which is open source project called Microx for testing and mocking. Actually, even I use it in AsyncAPI generator. So every single client we generate. So on the pull request, we want to make sure that the clients that we modify and generate are actually working. So we have to have some mocks. We have to be able to, even on the pull request level, to test if my generated client is actually able to publish or consume events. So that's what we use Microx. And it's used in different ways. Basically, the whole concept of testing and mocking, because you have all the details in AsyncAPI documents to achieve it. You can mock messages basing on the schemas. You can mock consumers and producers. So I really encourage you to do it. Not only on local environment, like we do, for example, with AsyncAPI generator, but also we can do it on global environment, organization environment. Yes. And last but not least, again, remember my phrase, docs is just a side effect of the investment. Developer portal solutions, there's, I noticed 3 different patterns. One is the eBay pattern, where you have a lot of money in your pocket. So you're going to create your custom solution. But also for them, I understand approach that they want to build everything custom because they monetize the API. So when you're thinking about really monetizing an API, you really have to carefully think if you want to use something open source and just put on top of it, or you actually, maybe it makes sense to build something from scratch, like it's in eBay. But there's a really great open source project, Event Catalog, which is like purely for teams that do async. It really does really super fancy stuff with async API documents. When you upload a large number of async API documents from your organization, it can extract a lot of details from it, like the flow. It can discover, like, for example, the flow of the event from the consumer to the producer. What's gonna happen if you're gonna disconnect one of the services that is producing event, and who's gonna be affected by it. So it's like a developer portal, but on steroids, with much more useful information for the organization. And last but not least is another CNCF project I would recommend, Backstage. It was donated to CNCF by Spotify. It's really customizable a lot in the Kubernetes native way. You can do CRDs, pretty easy to add your plugins. So that's what, for example, a TransferGo, as far as I remember, use. So again, remember at the end, docs are just a side effect. Like it was with Bank of New Zealand, they give you infrastructure, they extract schemas to make sure that they are widely visible in the organization. And as a side effect, they take your docs and publish it to the whole organization. The same with Lego. Docs is just like, hey, actually we can also publish docs because we have AsyncAPI document. So they do the same for teams. Like out of the box, you don't have to care about anything. Docs is a side effect. And yeah, remember, AsyncAPI initiative is an open standard. We're part of Linux Foundation, although we're organized a bit differently. So anybody can join. We don't differentiate if you're corporate or you're individual. So please feel free to join for more questions later. And yeah, thank you.